So, sorry about the technical difficulties. I will go through everything now. So, this is from the video you watched last night. I didn't expect you to memorize the units, but if you happen to remember them, that would be good. If you did not remember them, you can take a look at the reference table, which I linked right here for you. So if you go all the way to the bottom, there is your equation, right? So we have Q equals MC delta T, and we have all the units, right? Q is heat, M is mass, C is specific heat capacity, and delta T is a change in temperature, right? So it is not just temperature. It is very important that we are doing the change, right? The change, not just one of the temperatures. All right, let's go back to class kick. And let's see, I have M, we said that was mass. Okay, C we said was specific heat capacity. Okay, make that smaller. Q we said was heat, not QAnon. And T we said, very important, change in temperature. Did it get that? Nope. That was worth a try. Oh wow, that's so much easier. I'm gonna do that for the rest of the time. Change in temperature. All right, my units, the units that we have been using all year for mass, right? Okay. The specific heat one is kind of weird, right? It's not just one unit, it's a few units put together. So it's going to be joules per gram Kelvin. Okay, joules per gram Kelvin. And this is bothering me. Whatever, who cares? Okay. Units. Units for heat are joules. And units for temperature. Yes. Okay. All right, Celsius or Kelvin. And I didn't get to tell you about this in person, but these are free summer programs by the state, or by the city, right? So my tax money pays for you to do cool science stuff over the summer, so you should definitely take advantage of that. They have stuff like glass blowing, which I thought was super cool. So they're not that long. I think they're like a week each, but I would definitely check it out to see. Okay. This page is all notes. I'm not going to waste time in this video reading through the notes, but please take a look at them. And let's start doing the example. Okay, so for these questions, on each page at the very top, I put the symbol, right? Each symbol and what it means. Also, its units, right? So let's say you're reading the question and you're like, okay, how many joules of heat? Joules? What the heck are joules? Right? You could go up here and be like, look at all these units, right? There's joules. Where do I put that? Oh, I put it for Q. All right? So as you're reading these questions, right, if you don't know, look at the top. Okay. So Q is my X, right? How many joules? Good. Now I have how many joules of heat are absorbed when 1,000 grams, right, 1,000 grams. Okay, I know that's something. That's got to be something. Grams, though. Grams. What are grams? Let me see. Oh, grams. Okay, mass. All right, I'm going to put that in for M down here, and I'm going to put 1,000. It tells me 1,000 grams. Good. Okay, I keep reading. Okay, 1,000 grams of water is heated from 18 degrees Celsius to 85 degrees Celsius. Right? So think about you're taking the train and you're going from 23rd Street to Nostrand Avenue, right? You start at 23rd Street, so that would be your initial, and then you'd go to Nostrand Avenue, that would be your final, right? So bring that back to the temperature, right? I have from 18 to 85, so 18 is going to be my initial, right? That's where I'm starting. And final, right, is 85. That's where I'm going. Okay, and then how do I find the change? What's the change in temperature? So change is always final minus initial. Right, so my final temperature is 85, my initial temperature is 18, and that's going to give me, wrong, it is not going to give me 20 anything, it's going to give me 67. Alright, 67. And now I'm going to... Alright, there's no more question to read. Okay, how many joules? Okay, got that. Absorbed 1,000 grams. Got that. Water is heated from 18. Okay, got that. Now I look over here. Alright, I got my Q, got my M, got my... Oh, boy. I do not have C. Where am I supposed to get C? Okay, so let me come up here. And it says that C is my specific heat capacity. Okay, specific heat capacity. And here we are dealing with water. So, the specific heat capacity for water will always be listed on table B, right? So you find that right down there. Okay, and that's going to be 4.18. 4.18. Okay, and that's joules per gram Kelvin. Alright, great. So we got Q, we got M, we got C, we got delta T. Let's throw it in our equation. Okay, so it's my X. That's my 1,000, 4.18. And 67, right? We need to be extra, double, triple careful that we're not taking this one, we're not taking that one. We have to do the delta T, right? Because we're looking for the change, right? So from here, all you would do is punch it into the calculator, right? So I have X equals 1,000 times 4.18 times 67. And I punch that into my calculator. Let's see, 1 times 4.18 times 67. And that gives me this nice gigantic number, 280,060. All right, and okay, so I put that here, 280,060. Don't write commas. Don't put any commas in your numbers. Alright, and then my last thing I gotta do, I'm like, okay. Q equals 280,060 kittens? Question mark? Alright, Q. What is my units for Q again? I forgot. What's my units for Q? Oh, okay, they're right here. Joules. Great. So make sure you are including your units. Right, so I have my answer. Okay, all worked out. Good. And now my last thing is to decide whether it's endothermic or exothermic. So I'm looking and it says label it endothermic if it's positive, exothermic if it's negative. So if we take a look up here, right, our answer doesn't have a negative sign, which means it's positive. Okay, so down here it says positive means endothermic. Okay. Alright, so there is our first example. I was about to ask if anyone had any questions, but alas, there's no one to ask me questions, so I'm gonna move on now. Okay. So, example number 2. So this one is going to be a little bit different because we are not solving for heat. So we're going to take a look at what that looks like. Okay. So, it says the temperature of a 95.5 grams. Okay, grams. I recognize that. 95.5 grams. If I forgot, I can look up here, right? Grams. Oh, yes, that is mass. Yes. Grams. What is it? Grams. Where is it? Mass. 95.5 grams. And this thing hates me. Oh my gosh. 95.5 grams. I swear. Oh, my Lanta. 95.5 grams. Oh my god, I give up. I'm just writing them from now on because now I'm getting annoyed. Okay. So we got that. Good. Of copper increases from 25 to 48. Right, 25 would be my initial, and 48 would be my final. Okay, and to get our delta T, right, final minus initial is 48 minus 25 gives us 23. 23. Alright, back to the question. Alright, so copper increases from blah blah blah. When copper absorbs 849 joules of heat. Alright, so 849 joules of heat. Double check what you're doing here, because if we take a look up top, I've seen a few people get confused between heat and specific heat capacity. So this one says 849 joules, just joules, right? There's no G or K over here, right? Nothing, just joules. That means it is going in for Q, right? 849 joules. All right, and rest of the question, what is the specific heat capacity of copper? All right, they were being upfront with us here, right? They're telling us what we're looking for. So specific heat, C, right? That is what we are solving for. So now, right, we got that. All right, we're good to start plugging into the equation. So 849, 95.5, X, and 23. So now we just solve for X. So we can multiply these first to make it a little bit easier. And I need to do that, right? 95.5 times 23 is going to give us 2,196.5. And we also still have our X over there. So 849 equals that. All right, and in order to solve for X, to get X alone, we are going to divide both sides. 2196.5, 2196.5. All right, and those are going to cancel out, and leave me with X on this side. So X, to get X, I would do 849 divided by 2,196.5. And that will give me some big long answer, right? So X equals 0.3865240, blah, 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 right? Please be aware, I know that you guys love to not read things. Round to the nearest 100th place, right? That means 2 decimal places. Right, so 2 decimal places. This is a 6, so this is going to get rounded up to 0.39. Okay, speaking of 9, I see your guys' hands up. I will get to that in just a second, I promise. Okay, and then our very last step is to look at the sign of Q. So, I want us to be careful here, because I did mess this up this morning, right? Q is not your answer here, right? So make sure you're looking back at the actual value of Q. Luckily, these are both positive, right? And we said that positive, right? Positive means endothermic. Positive, okay. Okie dokie. So let me zoom out of that for a second. That way, if you need to copy or look at it, right, I'll erase all the other little bits and pieces there. Make it nice and neat. Okay. Alright, so I hope this was a decent explanation. Again, I'm sorry about the technical difficulties. Alright, I'm gonna go upload this now and post it on Google Classroom and here also. Alright, bye guys.